All right, let's talk about incidence axioms. It's time to kind of add flavors to our geometry. All right, so let's look at the first one. I1 said if you have two distinct points, they will determine a line, which determine means that there exists only one line that contains those 2 points. Alright, so what this guy prevents is that we want to kind of give lines or kind of a straight characteristics. So this kind of gives a straightness of a line. Alright, so this prevents this kind of situation. Let's say you have two lines. Say you have two lines. So here is one line. And here, let's say here you have another line like that, and then you have 2 points in common. Say I'm gonna call it A and B. All right. So what the I1 is trying to prevent is this kind of situation. You can see that you have two distinct lines sharing two of the same points. All right. So I1 doesn't allow that, because if you have 2 points, then it determines a line, so which means that there is only one line having those 2 points, right? So it basically preventing this situation. So maybe I1 prevents this kind of situation, right? So this is bad, right? All right. Then how about I2? It says that when you have three non-collinear just means that all 3 points cannot be on the same line. Points determining a plane. So if you have three non-collinear points, there must be exactly one plane containing all 3 points. All right. So we are basically giving our geometry the concept of flatness. Right, so we don't. So when you have, so we're basically trying to prevent this kind of situation. So if you have 3 points, say A, B, and C, then plane will contain. So one plane contains all 3 points. Right. So I2 prevents another plane having the same 3 points A, B, and C, but a different plane. So it make it look kind of like this. So say you could have a plane, something like that, and maybe I'll make it look like this. Right, then you go on here. Maybe you can't see that part. And hopefully you can visualize what's going on, right? So in order to have another plane go through those 3 points, we kind of have to bend the second plane, right? I2 is kind of trying to prevent that. So once you have 3 non-collinear points, then there must be exactly one plane containing all 3, right? So again, this I2 prevents bending of the plane. All right. Then let's look at the I3. Right. I3 said that if a line meets a plane in 2 separate points, then the entire line has to be in that plane. Right. So now we're talking about the interaction between a straight object and a flat object. Right. So flat object has to have some sort of a straightness characteristic to it. So what the I3 trying to prevent is prevents this situation. So you have a flat object, which is a plane, right? Then you have another line, kind of in and out of that plane. So you can have let's say, so we're trying to prevent this situation. Pierce through the plane once and then come back in and pierce through it again, right? So you can see that we don't want a line to behave like that, you know, come in and hit the plane once and come back and hit the plane again. So once you have 2 points in common, then the entire line has to be sit inside the plane, right? So that's what I3 is trying to give. So this is an interaction maybe between straightness with the flatness. All right. How about I4? It says that if 2 planes meet, their intersection is a line. So 2 different planes meet if their intersection is a line. Right? So basically what it's saying is that when you combine 2 flat objects, flat plus flat is equal to straight. Right? Again, we're basically trying to give a flavor that a flat object has to have some sort of a straightness characteristic to it, right? So we're trying to prevent something like this, basically the bending of the plane again. So when you have 2 planes meet, we can't have something like this. So let's say you have a curved intersection. So here maybe a plane might look like this. All right, and let's see, and like this, and the intersection might look like this, kind of a curved intersection with another plane, right? So we're trying to prevent, I4 is trying to prevent that kind of situation, right? So prevents. Alright, so I4 gives you the, when 2 flat objects meet, then it's going to be a straight object. Alright, so we see that from a Euclidean geometry. Alright, so I1 through I4 kind of gives how the line is supposed to behave and the plane is supposed to behave, and also a line and plane is supposed to interact with each other. Alright, so I5 is kind of like a minimum requirement. So it tells you the minimum number of points you have to be a certain object. So it says that space has to have at least 4 non-coplanar points, right? Because we don't want just say 3 points to be a space, because we have third dimension. If you have only 3 points, that will probably only define 2-dimensional object. So we have to have a 4 points at least. And also space contains at least 3 non-collinear points. Again, we don't want a space to be just 2 points, which is usually a linear object or 1-dimensional. And a plane has to contain at least 3 non-collinear points. Right? In order to become a plane, you have to have at least 3 non-collinear points. And the same for a line has to contain at least 2 distinct points. Right? So I5 is basically giving you the minimum number of points a certain object is supposed to have. Right? So since nothing from I1 through I4 doesn't prevent a single point to be a space. I mean, single point could be the entire space. It does not violate I1 through I4, but I5 is saying that okay, so in order to be a space, you have to have at least 4 points, and in order to be a plane, you have to have at least 3 non-collinear points, and in order to be a line, you have to have at least 2 distinct points. All right, so those are the incidence axioms. All right, that's it. I hope that this was clear.